Well, good day, everybody. We're off and rolling this week. We're going to do section 5.05, start that today. And it is about operations with complex numbers. Operations with complex numbers. Now, my guess is you have done some of this in Algebra 2, but basically, we're going to start with our basic definition that the square root of -1 is now going to be called I. And we're going to start there, and we're going to learn how to add, subtract, multiply, and divide with complex numbers. And so this is really strictly an algebraic exercise. And your best friend will be, do you know how to multiply with FOIL? If you remember that, first, outside, inside, last, that's the distributive property in disguise. And do you understand a difference of squares? Do you remember difference of squares? Which is a minus b times a plus b equals a squared minus b squared. So these are going to be your best friends algebraically today. And so I want you to keep that in mind. You'll see them pop up as we go along. So let's get started with complex numbers. So our definition is the square root of -1 is equal to I. So there are a couple of effects once we make this definition, and so let's go over those. First of all, we'd like to see what the powers of I look like. Okay, powers of I, what they look like. So what is I squared equal to? Or I cubed, or I to the fourth, or I to the fifth, etc. What can we do to figure those out? So I squared is the square root of -1 times square root of -1, which is equal to -1. Okay? So I is equal to the square root of -1. I squared is -1. So what's I cubed? Well, I cubed will be I squared times I. So it will be -1 times square root of -1, or negative square root of -1, which is -I. So I cubed is -I. I to the fourth is I squared times I squared, or -1 times -1, which is 1. Okay? So I want you to look at these. We have I, then we have I squared is -1, then we have I cubed is -I, and I to the fourth is 1. Now, if you keep going, if you look at I to the fifth, that's I to the fourth times I. Since I to the fourth is 1, this is just I. That's back here at the beginning. All right? That's back at the beginning, what we started with. Well, if we go to I to the sixth, that's I to the fourth times I squared, which is 1 times I squared, which is just -1. Oh, that's I squared. That's the second part. What about I to the seventh? Well, that's I to the fourth times I cubed, which is 1 times, and I cubed is -I right there. So we get -I. In other words, we get what we got for I cubed. What's I to the eighth? Well, that's I to the fourth times I to the fourth, which is 1 times 1, or 1. And that takes us right back there. So what we see is we get a pattern, and that pattern goes I, -1, -I, +1. And that pattern repeats every fourth power. It goes on and on. So when you do a simplification problem, Say like somebody comes up to you and they go, hey, what's I to the 173rd? And you go, well, I don't know. Well, what you want to do is you want to ask yourself, well, how many times does 4 go into 173? So 173 divided by 4 is equal to 43 1/4 times. So this is I to the 4th to the 43rd power, which is I to the 172, by the way. All right. But that means we have an I left over, or an I to the 1st, if you wish. I to the 4th is just 1, so that's 1 to the 43 power times I. And so that's just 1 times I, so we get I, all right? Which is the correct answer, and that's I to the 173rd is I. So what about I to the 174th? Well, it will be -1. How about 175th? It will be -I. And how about 176th? It will be 1. And so you're always looking for what powers of I to the 4th go into these large powers. Once you figure that out, then whatever's left over is going to either be I, -1, -I, or 1. Alrighty? So, next step. Let's go to the next problems. All right, the next thing to do is simplify square roots of negative numbers. So a lot of times you'll see something like the square root of -16. Well, what you do is you rewrite that as the square root of -1 times the square root of 16. So you isolate your perfect squares, you pull out the square root of -1. The square root of -1 is I, and the square root of 16 is 4, so we're left with 4I. And that's what we do when we have a negative under the radical. From now on, we do complex numbers, and we deal with them in this way, okay? And typically we write that as 2I square root of 10, and that's how we simplify the square root of -40. Okay? Any questions on that? Very basic simplification with complex numbers. Always, if you have a negative under the radical and you're trying to simplify, pull out that square root of -1. If you do that, then you'll know what you're doing. All right, let's go to the next slide. So finally, what we want to do is we want to define complex numbers, okay? What is a complex number, okay? And a complex number is this. It's a two-part number, all right? It's a number a plus bi, where a and b are real numbers, okay? Real numbers, all right? And I equals the square root of -1. So examples of complex numbers could be 2 plus 3i, square root of 7 minus 4i, okay? Pi plus pi over 4i. Those are examples of complex numbers. You can also have something like this. Just 2 is a complex number because it's 2 plus 0i. And 3i is a complex number because it's 0 plus 3i. So all complex numbers come in two parts. And once we define that, then we can decide how do we add, subtract, multiply, and divide these characters. So that's really what most of the rest of the lesson's about. So, first of all, we want to add two complex numbers, a plus bi plus c plus di. Two complex numbers. We want to add them together. What do you think you would do? Do you have an idea? Why don't you write it down and then come back and check in a second? All right, if you said collect like terms, then you would be correct. To add and subtract complex numbers, all you have to do is collect like terms. We collect the real parts together, which is the A and the C, and we collect the imaginary parts together, the B and the D. So in other words, this becomes A plus C plus B plus D times I. And so we add those parts together. Quick example, if I have 2 minus 3i, and I want to add that to 4 plus 4i, like this becomes 2 plus 4, all right, for the real part, plus then a negative 3 plus 4i. So I add the negative 3i and the 4i, and that gives me 6 plus 1i. All right? Collect like terms. All right? If you subtract, we can do the same thing here. 2 plus 3i minus 4 plus 4i. The way I do that is I write 2 plus 3i minus 4i, and then I collect like terms. 2 minus 4 plus 3 minus 4 times I, which is negative 2 minus 1i. Okay? So, collect like terms is how you add and subtract complex numbers. So, in general, how do you multiply complex numbers? Well, if you look at this looks very familiar to our old friend, the distributive property, which in algebra we often called the FOIL method, first outside, inside, last, where you multiply the first ones, the outside ones, the inside ones, and the last ones. Just a distributive property. So to multiply two complex numbers, you'd get a times c plus a times di plus b times ci plus bdi squared. Now, the key to notice that this here is this is a real part. These are imaginary parts, so we got to rewrite this. Collect like terms, basically. And this is an I squared. But I squared is negative 1. So this is really BD times negative 1, or negative BD. So we actually get AC minus BD plus AD plus BCI. So there it is in complex form. So now let's do this with an actual example. Same two problems we had, 2 minus 3i and 4 plus 4i. So we're going to multiply them. So this will become 2 times 4, 8, plus 2 times 4i, 8i, minus 3i times 4, minus 12i, minus 3i times 4i, which is, minus 12i squared. Now, the I squared is negative 1. So this becomes 8 plus 8i minus 12i plus 12, because it's 12 times negative 1. which is negative 12, and I'm subtracting, so it's a positive 12. So you've got to remember to change this every time. And now we write it in as a complex number, 20 minus 4i, collecting like terms. And now we have multiplied those two complex numbers. Okay? So let's go to my favorite part, division of complex numbers. So when we divide, you get like a plus bi over c plus di, which is a plus b times square root of negative 1 over c plus d times square root of negative 1. So the real issue here by division is we need to rationalize the denominator. We need to get rid of the square roots. That's what's considered simplest form. And the way we do that, if you remember, how do we get rid of a square root in the denominator? So let me do our problem here. 2 plus 3i divided by 4 minus 4i. And so essentially we want to get rid of a square root in the denominator. So here's our problem. And let's review how we would do that. If you remember, if I had something like, let's go 8 over 3 plus the square root of 2. How do we get rid of the square root in the denominator in this case? We would multiply by, if you'll remember, the word was the conjugate. It's basically the other part of the difference of squares. Because if you have a difference of squares, then both terms are squared. So we would multiply by 3 minus square root of 2 over 3 minus square root of 2. So this is a plus b times a minus b in the denominator. So the numerator would become 24 minus 8 square root of 2, but the denominator would become a squared minus b squared. So 9 minus 2. All right, a squared is 3 squared, b squared is square root of 2 squared, which is 2. And that would get rid of the square root in the denominator. So that's what we need to do here, is we need to get rid of the square root of negative 1. And so we're going to multiply by the conjugate of the denominator. And if we do that, this will get rid of the I, the square root of negative 1 in the denominator. So the numerator, we just need to FOIL out. 2 times 4 is 8 plus 8i plus 12i plus 12i squared. Okay? And the denominator becomes a squared minus b squared. So it becomes 16 minus 16i squared. Okay, now I squared is equal to negative 1 in each case. So this now becomes 8 plus 8i plus 12i minus 12 in the numerator, and the denominator becomes 16 minus 16 times negative 1, 16 plus 16. Okay? And now we can simplify. 8 minus 12 is negative 4 plus 20i. And then the denominator is 32. And we tend to want to not put it all over 32, but write the real part over 32 and the imaginary part over 32. Okay, so we split it up into two fractions. Okay? Want to see another one of those? Just for kicks? All right, you try it first. All right, let's go with 1 minus 2i over 3 minus 2i. And you go ahead and give it a shot yourself, rationalizing the denominator, which is division of complex numbers. Okay, let's see if you've done it right. All right, you should have paused the video and done it. So now, to do it right, you're going to do 3 plus 2i, 3 plus 2i. So notice how this is the conjugate. So you have a minus b times a plus b. So what's that going to equal? Well, the denominator is going to be a minus b squared. So a squared minus b squared. So it's going to be 9 minus 4i squared. Okay? A squared minus b squared. The numerator we got to multiply out. 3 plus 2i minus 6i minus 4i squared. Now, I squared is equal to negative 1. So this will give us 3 plus 2i minus 6i plus 4. And in the denominator, we'll get 9 plus 4. And now we can finish. 3 plus 4 is 7. Minus 4i, and the denominator is 13. So we get 7/13 minus 4/13 I. And so if you got that, then you did the division correctly. Alrighty, that is all that we have for this particular video. You're adding, subtracting, multiplying, and dividing complex numbers. To add complex numbers, or to add and subtract complex numbers, you collect like terms. To multiply complex numbers, you use the distributive property. Often in Algebra 1, we say you FOIL it. It's a nice way to remember it. And then you have to pay attention to I squareds. Those, watch out for I squareds when they show up. On division, then we rationalize the denominator using the conjugate of the denominator, right? Which leads to the denominator is an a squared minus b squared. We also get I squareds. We have to simplify to negative 1 along the way in this process. But in general, this is how you're going to do arithmetic with complex numbers. And now, eventually, we're going to show how we can mix some trigonometry with this as well. Actually becomes pretty cool. So thank you and enjoy this lesson.